In this video, we'll look at the theory behind acid-base indicators and qualitatively describe pH titration curves and how to select an indicator. And if you remember from Chemistry 1, we did titrations, and we took a burette and we filled it up with, say, something like a base. And we used it to try and determine the concentration of an unknown acid. And so we put a fixed amount of an acid, maybe we pipetted it out or weighed it out into an Erlenmeyer flask, and we added an indicator to it. And then as we underwent the titration, we added drops and drops of this basic solution out of the burette, and it would neutralize the acid. And the question is, how do we know when it's neutralized the acid? And the answer is, well, we don't. But if we can see the molecules, of course, we can tell. Of course, we can't. So we normally add something called an indicator. And so the indicator we used in the fall was something called phenolphthalein, and it is completely colorless when we start with a acidic solution, and as we neutralize it, it takes on a pale pink to a dark pink color. In fact, we normally look for the very first presence of a pink drop, and we say at that point there it's completely neutralized. So at this point here, we're ready to discuss the theory of indicators. So sorry this came about 4 months late, but here we are, we're ready to do it finally. So pH indicators are actually normally weak organic acids, and we can write a Ka reaction for them. So the indicator itself is an acid. In fact, this is going to have color 1, which in my drawing is yellow, and it's going to react with water. We'll just write that in white. And if it's a Ka reaction, then the acid is giving a proton to water, so it's forming the hydronium ion. All right, and now we're forming the conjugate base of the indicator, and we're going to go ahead and write that as In- because it's lost a proton, and so there's one fewer hydrogen, and because it's lost a positive charge, it is negative, and now this thing is color 2. So you can see that what we have here are two different forms with two different colors. Okay, so if we have both this and this present, then we have ourselves what we call a buffer. And do you remember the equation we use for buffers? Yeah, of course you do, right? It is the Henderson-Hasselbalch equation. So pH is pKa for our indicator plus the log of the base to the acid form. So the base here would be In-, and the acid would be HIN. So we've got something that looks like that. Now recall, right, when we've got the pH equal to the pKa, then this ratio is 1 because the log of 1 is 0. Also recall that when the pH is 1 unit bigger than the pKa, okay, then that implies that the log of this ratio must be 1. Okay, so for instance, if the pKa is 10 and we're at 1 unit above there, so this would be 11. 11 equals 10 plus, well, the answer must be 1. Now, when is the log of that ratio 1? That is when that ratio itself is 10. Or if you like, you can think of it as 10 to 1. Okay, now given that the In- form is blue, okay, I can kind of overwrite there a little bit. If you've got 10 times more of the blue form than the yellow form, the whole solution is going to look blue. All right, now if you've got your pH 1 unit below your pKa, so if the pH is pKa minus 1, that's going to imply basically the log of that ratio is minus 1. And if you take the anti-log of that, that's 10 to the minus 1, which tells you that ratio is 1 to 10, or 1/10. So now this ratio here, okay, is 1/10. Now you've got 10 times more of the acid form, right? So your acid form, if it's going to be yellow, I don't know why I picked yellow and blue, I guess I just like those colors, then we're going to have 10 times more of this yellow form of the indicator at this pH, and so the whole solution is going to look like color 1, which is yellow. So notice how this is really cool, right? So as the pH changes, when it changes so that the pH is 1 unit above this indicator's pKa, then it's going to predominantly be the basic form, which is color 2, which I picked to be blue. When the pH is 1 unit below the pKa, it's going to be predominantly the acid form, color 1, which I picked to be yellow. And when it's equal to the pKa, it's going to be a mixture of the two colors. So what we really want to do is ideally have the pH either way higher or way lower than the pKa. And when the pH is way higher than the pKa, color 2 will dominate. And when it's lower, color 1 will dominate.